All right, we're now recording.
All
So,
right.
all right. So I'm going to take this off. If you see that Ricky comes in because it's right in the middle of my screen, you can't see it. Do you see a blank box in the middle?
No,
Okay.
sir.
Okay, number one, do you see my Blackboard screen here?
Yes, sir.
Oh, you do see that. But you
Yes, sir.
don't see a blank box in the middle. No? Okay.
No, not right now, though.
Okay, good. That it's just the uh, what participants are in the class. It's you and me. So,
Oh, okay. Yeah,
okay.
yeah.
So here's the, I'll open the syllabus,
All right.
or I'm trying to open the syllabus. There it is. Uh, Now, I don't know if you'll see that. No, the screen sharing has stopped, so I've got to do a new screen share.
Hmm.
Okay. All right. Do you see the syllabus?
Yes, sir.
Okay. Had you had a chance to look at it before?
Yes, sir. I looked at it over a little bit last night.
Okay. All right. So then this is nothing new to you.
Yes, sir.
And if you, like I said, if you see that Ricky is trying to get in, let me know, because
All right.
I can't show this and see her too. So,
Okay.
yeah. Okay. So everything's see, we do start at 11 supposedly and go to 1:15, not 5:40, 4:45. But anyway, the campus and building, that doesn't matter anymore. We're all virtual. It says office and office phone. None of those make any sense either, so I
Yes,
just
sir.
blank those out. My email does make sense, so please
Okay.
communicate with me either through Blackboard messages or email. Okay,
Yes, sir.
I'll probably see the email before I'll see the Blackboard messages, but either way will be fine.
Okay.
All right, and my office hours. And we'll go over this in more detail when I show you my locator card. But basically on Mondays and Wednesdays, I only have office hours from 8 till 11:30. Okay?
Okay.
Because from 11:30 I start a Cal 2 class, and when that's over, I think I have 5 minutes before I start a physical science class, and then it's got a lab with it, so it runs until 6:15. So that's my Mondays and Wednesdays. So if you need to catch me, 8 to 11:30 is a good time. On
Yes,
Tuesdays
sir.
and Thursdays, I have a differential equations class before this one. So I'm up here in the office, which is a spare bedroom here. And the reason I'm here, my wife's downstairs in our office, and she's doing her work down there, and she tried to get me as far away as possible because I'm too loud. And so I have to have the door closed. If you ever look and see the doors open, say, hey, you need to close the door because otherwise she's going to be yelling at me. Okay, so anyway, I'm up here from 8 to 8:30. Then I'm in class from 8:30 till 10:45, and I ran over this morning. Then we start at 11 and go to 11 to 1:15, and then I'm free from 1:15 until 5. At 5 o'clock, I got a physics class that starts, and it's from 5 to 6:30. So that's my Tuesday and Thursday.
Yes, sir.
Wednesdays, just like Mondays, not quite just like Mondays, but I'll explain the difference a little bit later. Fridays were supposed to be closed, though I'll try to be checking emails, not all the time, but and getting things done. My wife has a laundry list this long, of things for me to do, honey-do list. So anyway, that'll be going. All right. The course description, you're used to seeing that kind of stuff, right?
Yes, sir.
Okay. The first part is the basic theory of linear equations and matrices. We'll do that in chapter 1 and 2. Real vector spaces, I think, are chapter 3. No, 4 maybe. Basis and dimensions, that'll be in the same chapter with real vectors. You'll see this coming up later. Linear transformations and matrices, that's a later chapter. Determinants is chapter 3, I believe, so this is not in the same order we'll be doing it. Eigenvalues and eigenvectors, if we get that far, that'll be a little bit later. Inner product spaces, diagonalization of symmetric matrices. That's a subsection in one of these others. Okay, we'll talk about that a little bit later. The odds are we're not going to finish all this, okay? And the
Yes, sir.
reason is this is supposed to be a 10-week term.
All right.
It's not, Okay, we're just a little bit short of it because at the end of July, our course management system, which we've been using, this ancient old system called Alliant or AS400, it dies. It ends at the end of July. And then we're going to this new system called Banner. Now, the administrators are being trained in Banner right now. None of us have had a bit of exposure to it at all. And they're trying to get everything translated over to that. But at the end of July, our old system ends, so that means we've got to get all the grades in and everything else that's in. We've got to get it in the old system by the end of July before it's over with, and then we're going to start transitioning to the new system, Banner. So that's why we're ending a little early. And so the odds are, and then summer's already short, and what they did, rather than setting us up for an 8-week term, they left the same hours we used last year in a 10-week term. So we're not meeting as long as we need to for an 8-week term. We're close, but not quite there. So I doubt if we're going to get everything covered. We're going to cover as much as we can if I'll just quit talking. Okay, the prerequisite here is Math 126, and you've had that. That was last summer, right? No,
Yes,
you were in 227 last summer, weren't you?
No, I didn't do last summer. I just ended 126 this spring. I'm doing 227 now with linear algebra.
Okay.
Yes, sir.
Yeah, so you've already had the 126. Now, there's actually a few things we'll be doing in this class that depend on stuff that will do in 227, but you'll probably get to 227 before this. But if not, I'll just give you a heads up and you'll know what it is when you get there. But it's not going to be much. Okay? The required text is elementary linear algebra. It looks like this. Can you see that?
Yes, sir.
Okay. Do you have this or an ebook or what?
I'm going to get it on ebook.
Okay. All right. Did you see that I put the WebAssign class key out there?
Yeah, I saw it.
Okay, good. That if you need that to get your ebook, that's the only reason I put it there, so you can use your ebook. I don't make assignments on WebAssign, but they're there for you to use as practice problems, to tutorials, but mainly to use that class key so you can get your book. Okay. And this is the 8th edition. I want to make sure, I got that updated. It says 2017. I thought it was more recent than that. But let me just check and make sure that I put the right date down. Yep, that's the most current date. Okay. And anyway, and you'll find, and I think when you were in my class before, I had the tablet computer that I was able to write on the screen and work out the problems on the screen.
Yes, sir.
Last spring, that computer died. After we left campus, I taught for a few weeks. Those first couple of weeks, everything went fine, and that computer just died on me. And what I was hoping it was the adapter and the battery. I knew the battery was weak, but I thought it might be the adapter too. And I thought that's why the battery was weak. So we ordered a new adapter and battery. FedEx delivered it to somebody else's house, or they just threw it away or something, but we never got it. Had to reorder it, and this time it came UPS. They got it to us actually a day early. So I got back on and was able to use it, and the old computer was back up and running again. And in about 4 days, it died the second time. And after that time, I could not resurrect it. And so they promised me another computer, and they delivered it in a few days, but it was locked under somebody else's name, and I had no way of unlocking it. So I let them know that and said, and by the way, and I'd asked for just 2 things on it: Screencast-O-Matic, which I'm running now, and WordPerfect, because a lot of my tests were in WordPerfect. And they said, yep, we'll get it ready for you. Well, when I couldn't unlock it, I called them back and said, look, I can't do, you just do this. So I said, no, you can't do that. I'd have to be on campus. They said, oh, that's right. You can't do that, can you? So we'll get you another one. I said, well, by the way, this computer, you did put Screencast-O-Matic? Oh, no, we forgot. I said, well, be sure to put it on the other one. Okay, yeah, we'll get it all set up for you. And I said, and did you put WordPerfect on? Oh, I don't have WordPerfect. I said, I know you don't, but I know somebody does there. I've followed your emails, because they copied me on them. I know someone else does. And she said, bring it by and she'd load it. Okay, we'll get it all taken care of. We'll get it all taken care of. That was back in late March, early April. I was teaching off an old Dell computer we had here at home, which didn't have the writable screen. It didn't have Screencast-O-Matic. It was a different operating system, and it was really, really awkward to use, but we managed to limp through it. And I kept thinking, where is my new computer? Well, when the term ended and I still didn't have it, I started contacting them. Look, am I going to get a different computer or not? I got this one sitting down here I can't use. I thought you were going to swap it out. Yeah, well, we'll do that. We'll get it to you. And then they said, well, no, actually, we've given out all our other computers. So they weren't getting one ready for me. Yeah. And we're going to have to get that one back and load it up for you and get it so you can, unlock it for you. So they came and picked it up. When was that? I think it was Monday or Tuesday. Yeah. And they picked it up on Tuesday, and then I had to go to campus yesterday morning and get it. And they had just about everything on it they had said they would. I had forgotten to tell them I needed one more thing, but I was able to get that on it. So anyway, but this computer doesn't have a writable screen, so I can't write on it. What we'll be doing is stuff like this. I'll work the problem with you. Hopefully you have pencil and paper there. I'll be working in ink because it'll show up better. And I'll hold it up in front of the computer, in front of the camera, so you can see what my work is if you can't get the same thing I do. Okay?
Okay.
So now, the trouble is, Screencast-O-Matic down here, I don't think will pick up the camera. This morning in my first class, I tried to get it so it would, but then it wouldn't record. So it was just really, really awkward. I found out the only way I could get it to record if I only did the screen and didn't do the screen and the webcam. So it won't record that. So what I'm going to do, I'm going to leave on, and I'll show you this in a few minutes. Remember how we had all the classes out there on YouTube videos?
Yes, sir.
And what I used to do, in fact, that's what you used last time.
Yeah, that's what I did.
Yeah. What I used to do when I was teaching in a class, as soon as I would teach material and I'd load it onto YouTube, then I'd delete the previous time I had taught it. Well, I'd leave them all out there until I did. That's why you had them there that you could do. Yes, well, I don't want to delete the ones that have the writing on the screen. So I'm going to leave the old ones out there that have the writing on the screen, and I'll put the new ones. And we'll talk about this later when we get there. So anyway, that's what's happening. Okay, it's a pain in the neck and I'm talking too much. Okay, so let's go scroll on down. Okay, the rest of this is all Cengage Unlimited. You know all about that, right?
Yes, sir.
Okay, so I'm not going to go through all that, but I feel like this is a big commercial in the middle of our syllabus. Okay, you know all about Blackboard, right?
Yes, sir.
Okay, here's the bad news. The syllabus is out there. There's no handouts to speak of, but when I do give you a test or whatever, just like we did before, there'll be take-home. So this time, rather than you having to come pick them up or me emailing it to you, I'll put them under Blackboard messages. Okay. Now, like I said, I used to make out all my tests in WordPerfect. However, I don't think y'all can do WordPerfect. So what I had to do, and that's why I wanted them to send me WordPerfect so I could translate WordPerfect to Word. WordPerfect will do that without too many errors, but Word screws up everything if you try to import a WordPerfect file. So that's why I wanted WordPerfect on the computer they sent me. They never got it. Now that I have it, but I had to go on and finish doing otherwise. So either I retyped them in in Word. Well, actually, we got Word on this whole computer, WordPerfect on this whole computer back here. My wife found a copy on the internet, so she was able to get it for $24 or something like that. Put it on, and so that's what I used. So some of them I did translate to Word. Others of them are still in WordPerfect. What I'll do with the WordPerfect files, I'll take pictures with, my wife got a new iPad, and it has a pretty good PDF picture maker, So I'll take a picture with the iPad, and it converts it to a PDF file, so I'll be sending you a PDF. Or I'll send you a Word document, one or the other. Okay, so that's what we'll do for that. And those will be the handouts. PowerPoint shows this book has absolutely none, so I can't do any of that. So what I'll be doing is showing you through the camera. And then the rest of it you've read a dozen times, I bet you. Okay. Student learning outcomes, there are course student learning outcomes, they're all here. We'll have a test at the end of chapter 1, 2, 3, 4. Hopefully we'll get there. Maybe 5, 6. I don't know how far we'll get, but as far as we get, you have a test. Now, a research paper is required. We'll talk about that a little bit later. You remember that fondly, I'm sure. Okay. And the research paper can't be dropped, and whatever the last test is, that can't be dropped. But I will drop the lowest score from the earlier test.
Yes, sir.
Okay, so the research paper is not droppable, and the last exam, whatever that last exam is, that's not droppable. Okay, but the earlier, I'll drop the one lowest score from the earlier group. Okay, you won't need it anyway. I know you. Okay, now here's where some changes occur. Dr. Davis had us put in, after this paragraph here that you've read in every syllabus you've had for years, after that, this one that starts with virtual classes, this one she had us put in this time. So I'll try to get all this on the screen now. And here she says, you're to attend based on the scheduled days and times of the class, which you're doing, you're going to do, I know you're going to do it, and blah, 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 all this stuff about how you have to do. In a separate email she sent us, something we had to agree to is that we don't count attendance from attendance, that we count it by work done. And it just is, I mean, she's telling students one thing and telling us the opposite thing. And the thing is, be here, do the stuff. I will give you a little assignment every day, and that, in case you can't be here, that will be your attendance for that day. Okay? Not that it really matters, because you've been here one day, that's really all that counts. But I want you here every day. Okay?
Yes, sir.
And then they say these are all your technology requirements. I know that I had people last term, of course, they couldn't help it. They didn't sign up for a virtual class, but they were doing off phones and everything else they could do. They didn't have everything here. Don't sweat it if you don't have all this. We'll manage. Okay?
Yes,
Testing will be just like you've done before. I'll give you the test. You send them back to me. Now, let's talk about that sending them back to me. If you have a way, and most of the smartphones do have an app now, free app, that you can take a picture with your smartphone and it automatically goes to a PDF file. That's what that iPad does. Okay? Mm-hmm. But if you don't have that or don't know how to do that, you can take a regular picture with it and send me the picture. Yeah. Now, here's the thing I want to warn you about. And you're probably really good at this, but I had some students last term that were not. Okay? Of course, they weren't prepared for it. When they would send me a picture, a lot of what I saw was their shadow and the shadow of their phone, okay? And whatever was underneath that shadow, I couldn't read, okay? Yeah. Because that's all they could do. That's all they had to deal with. So what I suggest is get oblique lighting coming in from the side somewhere so it's not got your shadow in it, and try to do that. And then also, if you have a scanner, you can do it. Just scan it and do a PDF and send it to me that way. You can do a PDF off your phone or an iPad, or you can take a picture. But if you take a picture, try to keep the shadows to a minimum, okay, and get oblique lighting. Good, strong lighting, but make it oblique. Now, if you're using a very faint pencil, once you've gotten your answer and you're pretty sure it's correct, you might want to write next to your answer, how it'll be if there's room, do it in ink as well, so it'll be easier to read. But if you got a good dark pencil, it'll show up fine. But I had a few people turn in stuff with very fine lead, and it was really, really hard to read, especially if there were any shadows in the paper. So that's how we'll do that. And then you can either send me back as an attachment to an email or send it back as on message under Blackboard. Dr. Davis wants us to use messages under Blackboard, but I actually found I had some students, and I don't know what they were doing, but I could hardly ever open one of their files on messages. And I'd ask them to try it through Blackboard, and just about every time I could get, and as far as I could tell, it was the same file. It just wouldn't open in Blackboard, but it would open as an attachment to a message. Now, maybe they changed something, I don't know. But I had better luck reading their stuff coming off of an email than I did off of some. No problem. I got them right off the messages, and they were fine. So you can use whichever is easiest for you. I'll be checking both. Okay? All right. Now, you know all about withdrawal, and I'm pretty sure you won't be withdrawing, right?
No.
Okay. And then makeup work, I really don't know what makeup work when you have take-home tests are anyway, but anyway, if you need to do it, we'll work it out. Okay. You know all about plagiarism and all that kind of stuff. Cheating, just don't do it. Don't do either one of them. Professional decorum. Now, here's something that's really important, okay? And we really need to spend a lot of time on this, okay? I do not want, especially if you turn your camera off, I do not want you eating or drinking. No, I'm just kidding. I mean, how would I be able to tell, okay? Or I don't want you wearing your hat, okay? How would I know, and what difference does that make, okay? Or sunglasses or earphone. I don't care, okay? In fact, like I told my Sunday school class, I said, I'm not going to stand up so you can see what I'm wearing underneath this nice looking shirt. So you can wear whatever you want to. I don't care. Okay. So, all right. If you have any course concerns, please come see me. Let me know, and we'll try to resolve them. But if you don't feel like we're getting good resolution there, Dr. Pruitt's next the department chair is next, and I'm the department chair, so come see me. No, okay. And then Dr. Pruitt, then Dr. Davis, whoever will get them resolved. But try to let me know first. You've heard all about discrimination and harassment, right?
I don't know how I'm going to discriminate anybody from a computer.
Yeah, exactly. Okay. Disabilities. Actually, I have one person in my later class that has some type of disability that I don't know how I can accommodate him. I mean, because we're not even in that. If he needs, I don't know. We'll figure it out. But anyway, I got 2 forms on them, so we'll figure that out. Here is the college calendar straight off the academic calendar on the web page. I just put the appropriate things here. A couple of things to note. Okay. Now, this is a huge, huge gripe of mine. I have gone to the calendar committee and said this in just about every way I could. I've emailed them. I've done all sorts of things and begged them, please do not ever start a term with classes beginning either on a Tuesday or a Thursday. Always try to start on either a Monday or a Wednesday.
So you can at least get both classes.
Okay. Just think about this week even. We're meeting today, right? First day of class.
Yes, sir.
Monday's a holiday. We'll meet again on Tuesday. Okay? So we'll have 2 classes. Wednesday, when those classes meet, the Monday, Wednesday class, that'll be their first class. So we'll be 1 week ahead of Monday, Wednesday classes, right from the get-go.
All right.
Okay? And guess what else they do? On July 4th, they're giving us the holiday. Guess when? Monday the 6th. They could just have easily given us the holiday on Thursday the 2nd. Because we don't have class on Friday anyway. Okay? Yeah. Why did they not do Thursday the 2nd? So what will it be? Tuesday, Thursday classes will be a week and a half more than the Monday, Wednesday classes.
Yeah.
And they just will not let us, because administrators are not in the classroom, and frankly, they don't seem like they care about the classroom. They just want to put down whatever is convenient for them. And I've emailed them and said, look, can we change that to the holiday being on Thursday the 2nd? And I explained exactly why. Not a word back. Not a word back. They're not going to do it. Okay. So anyway, but the good news is, for us, we get that extra week and a half. Those poor Monday, Wednesday folks, they don't. But you don't get cheated as much as they do. So your physics class, yeah, even shorter than normal. And it's already a short term. Okay? Yeah. All right. Let's get off my thing. And then if you want to, after you've read and understood this, have any questions, ask me the questions, then print me a copy of this page and send it to me or whatever. In fact, that could be your first assignment. That's today's assignment. Once you've reviewed the syllabus, if there's any questions you have on it, read this, print off this form, sign it, date it, and send it to me. And that'll be your homework for this week. So, Ricky, if you're listening to this later, there's your homework for this week. Do the sign that form. Read the syllabus first and ask me any questions you have, but then sign that form. Okay. Now, any questions on the syllabus?
No, sir.
Okay. So let's go to, now you're probably going to lose the screen here. I've got to move you. You're in the way. Don't you know you're in the way? Okay, here we go. I'm going to end this. The screen sharing stopped, didn't it?
Yes, sir.
Okay. I will bring it back in just a minute. I need to go back to, I have to minimize this. Okay. Get out of the syllabus and go to the locator card. Okay, as soon as it comes up, okay, it's coming up now. Okay, so let me get back in the class. Okay, you got me again? Poor thing, okay. And let me get my screensaver up here, right there. Okay, can you see my locator card now?
Yes, sir.
I'm going to try to move this out of the way. Okay. Now, this is basically stuff you've already seen before. This is summer 2020. Office phone. I'm not on campus, so I don't have an office phone. My email address is still good. Okay, all that stuff. Now, here's my activities during the week, and I'll try to be as general as I can with it. Mondays and Wednesdays, I'm up here in the office, the bedroom, okay, from 8 in the morning until basically 10:30. They say we have to put our lunch hours on here, so I put them on here. I won't necessarily be at lunch that long, but I probably won't be eating in the bedroom. I'll go downstairs to eat, so that's why I put it there. So 8 to 10:30, I'm usually up here in the office working on stuff, and then lunch is up 10:30 to 11:30. At 11:30, I have Cal 2. It goes until 12:25. I have a big 5-minute break there before I start my physical science class. It goes until 2:30 to 2:30 to 4:45. Then the lab begins after that. It probably won't go till 6:15 every day. Some days it might. Some days it might go longer, but most days it probably won't, because all I can do is set them up for a virtual lab and then leave them to it. I'll stay with them as long as they want me, but most of the time they want to do that on their own pace at their own time. So we're through. So I won't necessarily be, I'll be working at least until 6:15, but I won't necessarily be online till 6:15. Okay, Tuesday and Thursday, I'm in the office from 8 to 8:30, At 8:30, I begin my differential equations class. It goes until 10:45, though today I went too long. And then this class starts at 11, not at 11:30. Where were you? No, I'm just kidding. Okay. It goes 11 until 1:15. So at 1:15, I'll start lunch. Technically, it's going to be an hour. It probably won't be an hour most days. But then I'll be back in the office from 2 until 3. Now, 2:15 until 3. Now, you might say, what's the difference here? Here you have office, 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 but there you have office advising. Well, I don't know if you're familiar with it. We now have this thing called the Virtual Advising Center. Did you go to it?
Yes, sir.
You did? Okay. So you know what that's all about. So I have to commit 5 hours a week to the Virtual Advising Center. So they can schedule students for me then. Most of the time, I won't have a student every half hour. There's been a few days I have had them every half hour, but most of the time I won't, okay? So when it says office advising, like here, here, and here, that means I may be advising students at that time. Most of the time I won't be, but I may be. So here's 2 hours here, 2 hours here, and 1 hour here. So at those times, if you try to get in touch with me and you can't get me, the odds are I'll probably be advising another student at that time. But most of the time I won't be. Like yesterday, I had 4 hours of advising. I had 2 students, 2 half-hour slots out of those 4 hours. And one of them took me probably 5 minutes, 10 minutes at the most, because all he needed to do was change his major, okay? And so I helped him do that. The other one probably took 15 to 20 minutes, okay? Sometimes they go over their time lot, and that's fine too, as long as I don't have one in the next group. So that's what the difference between office and advising. I'm free in the office from 2:15 until 3. Then I'm usually in the office, but may be advising from 3 to 5. Then at 5 o'clock, I start my physics class, and it goes until 6:30, and that's the end of the day. Now, that will go till 6:30 every day. There's no way we'll end that early. It doesn't have a lab. It's straight class. Okay, and then the Wednesdays, just like the Monday, except from 8 to 10, I will be in the office, but I may be advising too. But from 10 till 10:30, I'm in the office, pure, plain, not necessarily advising. Eat lunch sometime between 10:30 and 11:30. Then the rest of the day is just like my Mondays. And on Thursday, just like Tuesday, in the office from 8 to 8:30, differential equations, followed by 15 minutes. Most of the time I'm not in the office. I'm going to run down and get a snack or something because it's a long time till lunch. Okay, and then this class goes until 1:15. 1:15 I actually have my lunch, and then in the office, not advising, but office, from 2:15 until 3, advising from 3 to 4, then just office hours from 4 to 5, and then my physics class goes from 5 to, let me see, did anyone come in? No, 5 to 6:30. And then the college is closed completely on Friday. Now, on past summers, we've been open the Friday in May and August, but closed on Fridays in June and July. This time we're doing everything in 4 days, 10-hour work days. Actually, my work days are 10 hours and 15 minutes, 10 hours and 30 minutes, 10:15 and 10:30. So I'm more than enough hours there. Now, does that mean I'm going anywhere? Most of the time, not. But I'm not going to be constantly checking emails or messages or other things like this. I will occasionally, but I won't be constantly on there. So you can contact me on Fridays, but no guarantee I'm going to be in the office. My wife has a laundry list of honeydew things to do from now till the towels come home. So I'll be busy Fridays and Saturdays. And actually, this weekend we will be going up to Smith Lake We have a place up there. Karen's family had a place up there, and they want to get together, even though we're technically not supposed to, but they've been safe, we've been safe, so we're going to sort of have some time together there. And up there, the internet is terrible. It's DSL, and it's terrible DSL. And I think one of our nephews is going to be there with Karen's nephew, and I know he's going to be on his Wi-Fi every instant he can, and probably the rest of them will too. So the way to get any internet is almost impossible. It's weak as it is, and with everybody trying to get on sharing that same little signal, it's going to be pretty miserable. In fact, they may leave early just because they can't stand being away from the internet. All right, so there's my locator cards. So I'm going to lose the screen for a moment here too, okay? Stand by for that. Okay. And minimize this. And minimize, okay, let's keep going. Okay. Research paper instructions. I think you probably remember this from before, so we won't go into gory detail here. But if you have any questions, feel free to ask. I should have said that before. Did you have any questions on my locator card? Or the syllabus? Okay. All right. Research paper instructions. These are all right off the blackboard. Okay. You've seen this before. Any questions about it?
No, sir.
Okay. One thing to point out to you, because I see this a lot, I do want it at least one word process page of text. Now, double space, this is single space, so double space. And what I mean by a page of text, if you have a header up here, you don't have to, but a lot of students will put a big old header or something up here, and then the title, and then triple space or something, and then somewhere down here start typing, okay?
Yes, sir.
So a page of text will go from here all the way to the bottom of that page, and on the second piece of paper, start wherever your margin is up here and come at least that far. Can you see my cursor?
It's not showing.
It's not showing, the arrow's not showing?
No, sir. But I get what you're saying, though.
Okay, all right. That's one page of text.
Yes, sir.
I tell you, try to keep it between 1 and 2 pages. You can go over if you want to. There's no penalty for going over, but I don't want it to be a major thing, okay?
Yes,
You choose your topic, anything that has anything to do with linear algebra. We'll hit several possibilities as we go. We'll talk about several people that contributed to it. We can talk about several applications of it, phenomena that are described by it. If you find an internet application or demonstration that helps you understand it better than what the book and me say, by all means go with that, okay? I just realized I have my temperature. I'm wearing that, okay? I had to go get a shot. When was that? Monday afternoon, I guess it was. And shingles, they have a new vaccination for that. And because of my health condition, they wanted me to have that. And it's a 2-part thing. This arm's still a little sore, but it's getting better. Okay, so anyway, that's why I was wearing that. Now, so 1 to 2 pages of text. You've seen all this before. All the things that count off for in English, that still matters here. Content also matters, so make sure you have your ducks in a row. Oh, I meant to say this. You need at least one source, outside source. The book is a great source for ideas, but it's not a source for your paper. You have to get outside the book for your paper, okay? But it has fantastic ideas in it, and I'll try to point those out to you as we go, okay? But 2 or more are better than 1, but at least 1. It can be any book, journal, article, blah, 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 that you find in the library or anywhere that's a good source on the internet. Don't just get any bit of garbage they have on the internet, okay? But the text is not your outside source, okay? Now, when is it due? Technically not before the last day of class. Now, that's not finals. It's the last day that we hold class. But don't wait till the last day we hold class. You'll never have more time to work on the paper than you do right now, okay? You'll have physics labs coming out of your ears. You'll have all sorts of things. See if you can work on it as much as possible, as early as possible. In fact, within the next week, if you can get me your paper topic, that would be great. Like maybe when you send me that page off the syllabus, type on there what you want your paper topic to be. That would be a good thing. Or send it separate. I don't care. Email me. Whatever you want to do. Just let me know what you're going to write on. Okay? But the stick is that if you turn it in after that last day of class, you start losing points. The carrot, on the other hand, if you turn it in the month of May, now you don't have many days left, but if you get the paper into me in the month of May, you get 2 bonus points just added to your score. If you turn it in the month of June, you get 1 bonus point added to your score. You turn it in the month of July, you get your score, just your score. After that last day of class, you start losing points off your score. So get it to me as soon as you can. Now, here's one thing I ask for that most other instructors don't ask for. I would like you to print me or copy me a page from a source. If you happen to have a book that you're using as your source, not your textbook, but some other book, you can just copy a page from that source. If you get something off the internet, print me a page, just 1 page. You may have 3 or 4 different sources. Pick any source, 1 source, and get me 1 page from that 1 source. That's all I need, okay?
Yes.
And turn that in when you turn in the paper. So any questions?
No, sir.
All right, so that's the research paper. So I'll lose you again for a moment here as I go back to all right, you did, okay. Let me pull this up. Okay. Are you using an ebook, you said?
Yes, sir.
Yes or no?
Yes, sir.
Yes, okay. Did you need the class key?
I haven't searched the book yet.
Okay. If you need it, here it is. It was right there in Blackboard. It's called WebAssign Class Key. So if you need it, there it is. Now with that, the people at WebAssign or Cengage or wherever it is, he asked me, I said, yep, put out whatever you want to put as sample problems from every section. I told them what sections we were covering. They're all there. If you need extra practice problems, if you need tutorial, if you need anything that's on WebAssign, there it is. You can use it, okay? I don't require it. I don't require that you do these, but if they're helpful to you, I want them to be at your convenience, okay? But if you need the class code, and this is the key right down here, all that stuff, the stuff is just, here is the key. Oh, I forgot. Did I bring this up?
No, sir.
Oh, wait. I'm sorry. Did I bring up the research paper stuff? I probably forgot to do that, didn't I?
No, sir, you didn't bring it up, but I understood everything you were saying.
Oh, okay. Sorry about that.
It's okay.
Okay. Can you see that?
Yes, sir, I see it now.
Okay, yeah. There is the code. It's just this part here. Lawson.al and then 8 digits with a space in between the 2 groups of 4. Okay? Can you see my cursor now?
Yes, sir.
Oh, you can. Okay. So that's the key. All this is just explaining which section it is. Okay. This is, I don't know why that's in there twice. I should take that out. Okay. I didn't realize that. Okay. In fact, let me see if I can take it out now. No, I can't. Okay. Never mind. All right. So that's that. Okay. Now I'm going to lose this again. Screen sharing stopped again. I wondered why it was so easy last time to do. How did I lose Blackboard? That wasn't supposed to go away. I must have hit the wrong. Sorry about that. I've got to get back Blackboard. This is not an easy thing to do. What do you notice much difference between the 2 Blackboards, the one you used your first few years and the one that we're using this year?
Well, the last one, if the teacher sent a message, I could get it right then.
Yeah.
This it doesn't send it like right then, so you don't see it unless you go in and look at it.
I know. This to me is not nearly as good as the old one.
Yeah.
Of course, I was used to the old one. I understand all that, but there are a few things that are a little bit better. Here's one thing that's not. They always go to this activity stream, which I have absolutely no use for, and yet that comes up every time. Okay. I'd rather they came right to the courses because that's what I use there. Okay. Okay. Got it. Okay. Now, we did research paper instructor, a webassign. Ooh, there's too many S's in webassign, isn't there? Okay. YouTube videos. That's what we're going to do next. Okay. As soon as this comes up, I'll get back in Zoom. Once I get in Zoom, I'll share the screen. Okay, can you see those?
Yes, sir.
Okay. Now, I don't know why this is in the middle of my screen. It needs to be at the bottom, and it just keeps going back. Okay. Now, you see before, there are no PowerPoints, so I worked everything out on my writable screen. Every one. Okay? Now I don't have a writable screen, so I'm going to be holding it up in front of the camera, and that's what you'll see. I don't believe it'll be recorded, so therefore, I'm going to leave these on here, okay? And they will be up here at the top. The new ones that I do, I'll put those on as well, and I'll put them down here at the bottom. Well, I mean, I don't put them there. That's where they go. So the newest ones will be at the bottom, the older ones at the top. Now, the only one I will delete is probably this one, the one that says syllabus from last time, because that's what we're doing now, and there's not much material in that. So I'll probably take that one out. But the rest of these, I'll leave them there so you can see what I did the last time I taught the course, and you can listen to what we do this time, and they'll be at the bottom. So there'll be more of them out there, but I'll leave them all there. Does that make sense?
Yes, sir.
Okay. All right, so we've gotten those done. Okay. Now, the rest of the things here, and I doubt if you can see this. Oh, yeah, you can still see this?
Yes, sir.
Okay. Education Portal and Slater are two websites that either I found or students told me about that they found useful. And if you find something you find useful, write your paper on it or just send it to me. Then if I see that it may be useful, I'll put it out there as well. These are all web links. You just click on it and you go there. Now, this is the library web link. This is Lawson's library web link. And it's pretty handy, pretty interesting stuff. So I put this here in case you need that for your research paper or just for general reviewing or whatever. So that's the syllabus. Do you have any questions on any of that?
No, sir.
Okay. So we can get started on linear algebra. So what I think I'll do is get out of here, minimize that, and where I think I'm going to go now, not that it's useful, but just in case it might be, is a new share. I'm going to put the whiteboard up. Now, if I need to, I will use this, but this is really pathetic. There's text here, and text I have to type the stuff in. And I'm a terrible typist, and it doesn't line up well. It's a pretty miserable thing to do, but if it's useful, I will do that for you. This is a draw screen, and I can either draw straight lines, arrowed lines, freehand. That's what that represents. Now let's see what this is. I have no idea what that is. I can't see that did anything. Oh, I see. I don't think I want to do that, so I'm going to erase that, clear that. Okay. So most of the time I'll be freehand, and that's pretty lousy. Okay, stamps just puts those symbols in there. Spotlight just points to things. There's the eraser. I could have erased rather than clearing. Then I can do colors or other things like this, but nothing is very helpful. There's no pen I can write on the screen. If there was, I would be using it in an instant. Okay, so, but this will just be the background. Can you see that?
Yes, sir.
The whiteboard. Okay. So, any questions before we get started?
No, sir.
All right. So, does it almost feel like when you signed up for a course that said linear algebra that you were going backwards? Yeah, you thought, boy, we did lines way back there. And algebra, we've been through with that for a while. So why are we doing this? Well, we're doing this because linear algebra basically deals with what Chapter 1's talking about. Not only what Chapter 1's talking about, but this is where it begins. Systems of linear equations. Okay, now, I take it right now you don't have a book, is that right?
Yes, sir, I don't.
You don't, okay. So I'll probably put more on the whiteboard than I did normally. The last class, I think all three of them had their ebooks already. So I did. So what we're talking about is systems of linear equations, okay? Is the title of Chapter 1. 1.1 is an introduction to systems of linear equations, okay? So what do we mean by system of linear equations, okay? You know what I think I'll do is just write it on paper and hold it up in front of the camera, okay?
Okay.
And I'm going to use ink because it shows up better on the camera than pencil. Most of the time when I do math, I do use pencil, but because I want it to show up better on the camera. Here is a representation of an equation. A1x plus A2y is equal to B. Okay? Now, that's obviously an equation, right?
Yes, sir.
Okay. What makes it an equation? It's got an equal sign, right?
Mm-hmm.
Now, is this a linear equation?
Why? Yes, sir.
It is because both of the variables have
Excellent.
exponents of 1.
Yes, sir.
If that exponent had been 1/2, not a linear equation. If it had been 2 or 17 or 3/5, not a linear equation. If it would have been -3, not a linear equation. The only allowable exponent on a linear equation is 1 for every variable. Okay. Now, the A1, the A2, and the B, those are just constants. It can be any constants in the world that make the equation true. Okay? Now, those numbers can be any real numbers. Positive, negative, fractions, decimal, rational, irrational, it doesn't matter. Now, in this course, we're not going to use any complex numbers with imaginary components in them. We're not going to go there. We will maybe hit a couple, but not in a linear equation, not as a coefficient or as a constant at the end. So that's what a linear equation is. Now, what do we mean by and by the way, this is a linear equation, and we call this a two-dimensional equation because it has an x and a y.
Okay.
Now, certainly, the book doesn't say this, but I'm going to do it. A1x is equal to b. That's a linear equation, right?
Mm-hmm.
Okay, the maximum exponent, the only exponent you have is a 1. Okay, that's a linear equation. But this is a one-dimensional equation. How would you graph that? You do a number line here. You wouldn't do this, but you could. Put a number line there, the x-axis, and then pick the point that solves that equation on the number line. Okay, and usually there's only one. That would be b over a1. Okay, as long as a1 wasn't 0, that's it. That's your answer. This one, however, is a two-dimensional equation because you have two variables, two independent variables. So you have an x-axis and a y-axis. So this gives you anything on a plane, the xy plane, the coordinate plane, your xy board, right? That's a two-dimensional equation. There's also a1x plus a2y plus a3z is equal to b. That's a linear equation. Linear because the exponents for every variable is 1 and only 1. The constants can be any real number, including the constant on the right-hand side. This is a three-dimensional equation. Okay, you could represent that by space, length, width, and height. Okay, that would be a three-dimensional linear equation. Okay, now we use these three variables x, y, and z because in space that's what we usually deal with. 2 dimensions in a plane and 1 dimension vertical to the plane or below the plane, wherever. Okay. However, in the most generic sense, you're not limited to 3 dimensions. I live in 3 dimensions. Okay. I don't live outside that. Okay. I don't have a visual idea of anything outside that. But in linear algebra, you can go as many dimensions as you want to. So here is your definition of a linear equation in n variables. Okay. Now I'm not going to write it all down, but this is what it is. And notice we're not going to use x, y, and z anymore because we run out of alphabet really quickly. So if you have an unlimited number of variables, what we usually do is something like this. a1x1 plus a2x2 plus a3x3. These are all subscripts. Plus dot 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 plus a sub n x sub n is equal to b. Okay? That would be a linear equation. Notice these are all subscripts here. There's not superscripts. Those are not raised to powers. These are subscripts, meaning this is a variable, that's a variable, that's a variable. Every one of those is a variable. These are your coefficients for those variables. The only reason you have the sub 1s there and sub 2s is just to identify which variable you talk about and which coefficient that goes with that variable. That's why they have the same subscripts. That's a linear equation in n dimensions. Okay? Not just x, y, and z. You have x of 1, x of 2, x of 3, x of 4, x of 5, all the way up to x of n. An n-dimensional linear equation. Okay? All right. That's a linear equation in n variables. The a subs are your real numbers, any real number in the world. The constants b's, also any real number. Now, get used to this. That first coefficient there we call the leading coefficient. Now, there's nothing magical about why we chose that variable first, but whatever variable you choose to be the first one, that's a leading coefficient. And when we get a little bit further, maybe even today, you'll see why we really like to focus on that leading coefficient. Okay? Because we always want it to be a 1. It won't always be a 1, but we try our best to get it to be a 1. Okay? So, example 1 here is a bunch of equations. I'm going to write them down, and if you want to just call them out to me, and I'll, what you think? 3x plus 2y is equal to 7. Is that a linear equation?
Yes, sir.
Yes, it is, because both variables are only to the first power. Okay? How about this one? 1/2 of x plus y minus pi z is equal to the square root of 2. Is that a linear equation? This one right here. I don't know if you...
1/2.
1/2 x plus y minus pi z is equal to square root of 2.
Yes, sir.
Yes, it is. It doesn't matter what those coefficients are. They can be any real numbers. What makes a linear equation? The exponents of the x, the y, and the z are all 1 and only 1 and nothing but 1. Okay. How about this one? Sine of pi times x minus 4, or x of 1, minus 4 x of 2 is equal to e squared. Is that a linear equation? Sine pi times x minus 4 x of 1 times minus 4 x of 2 is equal to e squared.
No.
Why not?
Because it's equal to e to the square.
Yeah, but remember, e is a number. 2.7 blah, 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 blah. A number squared is still just a number.
Right.
So that doesn't matter. All that matters are the variables, x of 1 and y sub 1, are both raised to only the first power. That is a linear equation. No matter how weird and bizarre the constants are, it's a linear equation. Okay? How about this one? xy plus z is equal to 2. Now, I didn't address this, but let's see if you can catch it. Is that a linear equation?
Yes.
Actually, this one is not, because here you have two variables in the same term. So that term is actually a second power, because it's x to the first times y to the first. So that's actually a order or degree 2, not degree 1. If that had been a 7y, yeah, no problem. If it had been x times 15, no problem. But x times y, no. That is a product, which means the degree of that term is more than 1. The degree of this term is only 1. The 2, no sweat there either. The problem is you can't have a product or a quotient of variables. You can only have sums or differences, and then they have to be to the first power. Okay? How about this one? E to the x minus 2y is equal to 4. What you think about this one? E to the x minus 2y is equal to 4.
E to the x. No.
No, you're absolutely right, because this x is an argument of a function. It's not the variable. It is a variable, but it's not linear. This is not linear in x. This is linear in y, but it's not linear in x, because the exponential function goes off and goes to infinity. I mean, really, really fast. Okay? So that's not a linear function. You're absolutely right. How about this one? Sine of x sub 1 plus 2x sub 2 minus 3x sub 3 is equal to 0. Is that a linear function? This one right here.
Sine x1 plus 2x. Yes.
Okay, wait. Think about this. Sine x is not linear in x.
Right.
See, now this one up here, where the sine pi was in parentheses, that's just a number. Sine of pi is 0, in fact, okay? So that's just a number. Here, the sine is operating on your variable, and that's not linear, because the sine function does like this, right? Not linear. Yeah, so that one is not. Even though the x is to the first power, your sine is operating on that and makes it nonlinear. Okay, good deal. Now, a solution of linear equation in n variables is a sequence of n real numbers, s sub 1, s sub 2, s sub 3, all the way up to s sub n, that satisfies the equation when you substitute in those values. x1 equal s1, x2 equal s2, x3 equal s3. So if you can plug in different numbers, or some of them may be the same numbers, it doesn't matter, and make the equation true, then you have a solution. Okay. Now, if you think back, I don't know what math you took and when you took it, but you remember doing in math probably algebra, whether it was elementary algebra, intermediate algebra, or possibly even pre-calculus algebra. Remember when you did systems of equations?
Yes, sir.
Okay, remember, if you had that system of equations, there were usually one of three ways you could have answers. Okay, now let's just imagine they're two-dimensional equations, two variables. So everything fits in the XY plane. Think of your graph board, right? A Cartesian coordinate system. Okay, one equation, linear equation, always forms a straight line, right?
All right.
Okay, and then another linear equation, that's going to form a straight line. Now, if those straight lines were not, most of the time those straight lines would not be the same slope. And if they weren't, they're going to cross somewhere, right? Somewhere on that plane, you'll find the place they cross. And if they do cross, they're only going to cross once. Because they're straight lines going this way and that way, they're never going to meet again. That's going to be the only solution. So usually, a system of linear equations in two dimensions anyway is either going to have one solution, or, here's another situation. What if you had two straight lines like this, but they're parallel? Are they ever going to cross?
No.
No. So therefore, there's going to be no solutions. Okay? Now here's a third one. What if you had one straight line like this and the other straight line exactly on top of it? How many solutions you got then?
One.
No. It's right on top of it. Any point on any one of those lines solves the other one, right? They're on top of each other. So then you have an infinite number of solutions. In other words, they're the same lines. Okay? Okay. Now, that was true in two dimensions. If you move to three dimensions, this is a little harder to visualize, but it's still true. A linear equation in three dimensions is going to define a plane. Now, this is a bit bizarre. See if this makes any sense. It may not, and if it doesn't, don't worry, it's not necessary. But this is how my little sick mind works, okay? One dimension is like this. It's a line, right? It's only going in one dimension, okay? In a two-dimensional plane, a single linear equation is going to be just in one dimension in that plane, right? But the plane's all there, okay? When you're in three dimensions, that's in two dimensions. In three dimensions, a linear equation is going to be a plane. So you got three dimensions in the space, but two dimensions in the plane, okay? So you're going to have a linear equation in three dimensions is going to define a plane. Okay, so if you have a plane like this and another plane like this, how are they going to intersect? They usually are going to intersect in a straight line. One plane like this, another here, there'll be a straight line intersection. Okay? Or you'll have two parallel planes that never intersect. Okay? Or, remember three equations. Okay, you got three variables, x, y, and z. So you need three equations. If you have three planes, one like this, one like this, and one like this, then they're going to intersect either in a single point, just like your two lines did, or they will intersect in an infinite number of points, just like the same line did, or they'll not intersect at all. and that would be no solution. So even in 3 dimensions, you have a single solution, infinite number of solutions, or no solutions. And then I can't describe to you, but guess what? If you go to 4, 17, 45 dimensions, you're either going to have, you have to have that many equations. If you have that many equations and that many unknowns, you're either going to have one unique solution, no solutions, or an infinite number of solutions. Every time it's going to be that same possibilities. Okay. Now that's arm waving. Okay. Now, if you just have one equation, pick a number of variables. You get to choose. Two variables. One equation, 2 variables. Well, guess what? There's an infinite number of solutions for that. So let's just pick something like, let's just do x plus y is equal to, pick a number. Any number. 3. Okay? X plus y is equal to 3. If you have one equation but 2 variables, okay, you could choose 0, 3. You could choose 3, 0. You could choose 1, 2. You could choose 2, 1. You could choose negative 3, positive 6. You could choose positive 6, negative 3. You could choose 3.5 minus 1/2. Okay? There's an infinite number of solutions for that equation, right? X plus y is equal to 3. Now, if you had 2 equations and 2 unknowns, that's when you have only one solution, no solutions, or an infinite number of solutions. Okay? But if you just have one equation with 2 unknowns, you're going to have an infinite number of solutions. Anytime you have more unknowns than you have number of equations, you're guaranteed to have an infinite number of solutions. Okay? I hope I'm right in saying that. Okay? Now, if you were asked to give me the solution set for this equation, okay? Well, there's no way. There's an infinite number of them. But there is sort of a way, okay? Let's pick a representative value, say, for the y, okay? Let that be the parameter t, okay? It's their favorite letter to use as a parameter, t. They sometimes will use s, sometimes r. A lot of times they'll use t. So let's let it. So let's let y equal t. Okay? So let y equal t. Okay? And
yes,
t
sir.
can be any value you want it to. Any value. Okay? Now, let's write down our equation again. X is equal to, x plus t now is equal to 3. We'll subtract t from both sides of that equation, and you have x is equal to 3 minus t. Right? Sorry. All right. So now you have x is equal to 3 minus t. Here was your original equation, x plus y is equal to 3. Let y equal some parameter t, any value you want it to be t. Then plug that in for your y, that x plus t is equal to 3. Subtract t from both sides, you get x is equal to 3 minus t. What does that give you? That gives you a solution set. Your solution set is a set of all t's, ordered pair x, y, such that x is equal to 3 minus t for y equal t. Okay? That's a weird way to express it, but that's what I'm going to say. This is awkward, but this is your set of ordered pairs. Pick a t, any t in the world. Remember, we picked y equals 0 before. If you let y equals 0, then x is going to be 3 minus 0, so 3. Well, 3, 0 was a solution set, right? So this works for you. Any t in the world, that would be your solution set. Now, what we call this a parametric equation. You probably had this back in Cal 2 or 3. You used parametric equations, didn't you? Okay, here you're using them again. But these are all in a linear sense. Back then you could use anything you wanted to. Here it's all linear. Pick a value for one of the variables, a parametric value, t, and then solve the other in terms of that. Okay? So that's what we call a set of all solutions of a linear equation is its solution set. And when you have found this set, you have solved the equation. To describe an entire solution set, you use a parametric representation such as what we're going to do now. So we're going to do a couple of examples with this. This is example 2 and 3 in your text. So here's example 2. x1 plus 2x2 is equal to 4. Okay? Now, there's your linear equation. We want to find your solution set for that linear equation. Now, here's my little rule. Okay? Find the thing that's the simplest coefficient, the simplest term with a variable in it. To me, that's the x term, right? The x1 term. That's the simplest. Solve for that one. So that means you would subtract 2x2 from both sides. Okay? And then you have x of 1 is equal to 4 minus 2x of 2. And once you have that, plug in a parameter for your x2. Let x2 equal t. So x1 is equal to 4 minus 2t. Now, remember this is a two-dimensional problem, just two variables, x1 and x2. So this is going to be, your solution set is going to be a set of ordered pairs, two. So what would that ordered pair be? Your solution set, and this is the easier way to write it, your solution set is a set of all ordered pairs x, y, such that, now just put the parametric value in, 4 minus 2t, comma, t. The x value, then the y value. Pick a t, any t in the world. 0, fine. If you put t equals 0, then x is going to be, the y of course will be 0, the x will be 4. 4 minus 2 times 0. And 4 is 0 certainly works for that equation. Okay? So that does it for you. This is your solution. It's an ordered pair. I'm trying to read it backwards. 4 minus 2t, comma t. That's your ordered pair. That's your solution. Where t is any real number. And that's what they got in the book. Here's another one. Solve this linear equation. 3x plus 2y minus z is equal to 3. Uh-oh, SpaghettiOs. Okay? This one has 3 variables in it, but you only have one equation.
All right.
Now, I'm going to use a term here they're not using in the book, but it's useful for me. What we call this, the one we did before, has 1 degree of freedom. Because you have one equation with 2 unknowns, you get to choose one, the other one's determined. So you have 1 degree of freedom. Here, though, you have one equation with 3 unknowns. That means you have 2 degrees of freedom. Okay? And what that means, you get to choose 2 parameters. Okay? So again, I would solve for the one that's the easiest to isolate. And in my mind, that's the z, because it has a coefficient of 1. So I would move z to the other side and have 3x plus 2y. Bring the 3 over with that. Minus 3 is equal to z. And then let x equal t, that's their favorite, and let y equal s. I think they may do it the other way. They may let x equal s and y is equal to t. I don't care which way you do it. I think the book does it this way, so I'll do it this way. So now your solution set, the set of all ordered triplets, remember, now you've got 3 of them, and that would be s, comma, t, that's your x and your y, and then your z would be 3s plus 2t minus 3. There's your solution set. I didn't write it as a solution set, but that's what it is. Set of all ordered triplets, s, t, and 3s plus 2t minus 3. There's your z value. Give me 2 degrees of freedom, any s, any t, your z is fixed. Okay? All right. Your x would be 1 minus, they chose a different value and they wound up with a bunch of fractions. Now you may like fractions, and if you do, knock yourself out and use the fractions. I chose the one that was simplest so I wouldn't have fractions. So there's an infinite number of ways you can write those. They did x equal 1 minus 2/3 s plus 1/3 t when y is equal to s and z is equal to t. Why they did it that way, I don't know. And if you, however you do it, this is to me the easiest way. You pick your s and t, you're going to wind up with the same set of triplets. If you just choose one, you're going to get all the same sets. Okay, so far we've been talking about equations and solutions for equations. Now we're going to move to systems of linear equations. Okay, the last 2 we did, we had one equation with 2 unknowns and one equation with 3 unknowns. I guess you could technically say they were systems. Usually a system is going to have more than one equation. Okay, it may have a whole bunch of variables. So what we're going to talk about now is a system of M linear equations in n variables. Okay, that's what we're talking about now. M linear equations in, that's the word n, the letter n variables. I know there's too many n's in there and they're pronounced the same, but they're represented differently. Okay?
Okay.
Now things get a little more dicey because you have more than one equation and you have a number of variables. We use subscripts again to identify what goes where. So here's how we represent that. M equations with n variables. Your first coefficient is going to be a sub 1, 1. Okay, I'll explain what that means in a minute. Times x sub 1 plus a sub 1, 2, x sub 2 plus a sub 1, 3, x sub 3 plus ... plus a sub 1 n x sub n. Remember, you had n variables, so you have n of those. And that's equal to some number, and we're going to call that b sub 1. And then we have a12 x sub 2 plus a22 x sub 2 plus a sub 32 x sub 3 plus dot 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 plus a sub, I messed that up. That last one was a 2, 3. Okay, not 3, 2. 2n x sub n, and that's equal to b2. We have another one, a sub 1, 3 x. I messed that first one up too. X sub 1 plus a sub 1, no. I'm getting it all crossed up here. Okay. Okay. I'll show you what it's supposed to be. A sub 3, 2, x sub 2 plus a sub 3, 3, x sub 3 plus dot 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 plus a sub 3 n x sub n is equal to b sub 3. We'll keep on going down because I'm messing them up too badly. A sub m1 x sub 1 plus a sub m2 x sub 2 plus a sub m3 x sub 3 plus dot 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 plus a sub m n x sub n is equal to b sub m. Okay? Now, okay. Now this is messy. I apologize. Okay. All right. You got n equations, 1, 2, 3, 4, 5, 6, 7, up to m equations. N variables, 1, 2, 3, 4, 5, 6, 7, 8, up to n variables. M equations, n variables. Okay? We represent the coefficients by double subscript. The first one indicates which equation you are, and the second indicates with which variable is associated. So a sub 1, 1 is the first equation, first variables. A sub 1, 2 is first equation, second variable. A sub 1, 3, and so on. Second equation will always start with the first subscripts of 2, with the first variable will be a sub 1, second variable at 2, 2, the third one at 2, 3, all the way up to 2n, and so on, and so on, and so on. Okay? So this represents a system of m equations with n variables. All right. Now, notice the variables don't change. You always put the x sub 1s over x sub 1s, x sub 2s over x sub 2s, x sub 3s over x sub 3, and so on and so on and so on. The only thing that really changes here are your coefficients and your constants at the end.
Yes,
so therefore, to save some writing, and I don't know if I've told you this before, to be a good mathematician, I think you have to be a little lazy. Okay? Do you qualify? Okay? No, you're a hard worker, aren't you? Okay. Okay. You can still do math, okay? But to be a really good mathematician, I think you have to be a little lazy, because what we wind up with doing is, why don't we just eliminate the variables and just go with the coefficients and the numbers? And just remember what they go with, okay? Now, we're not there yet. I'm going to get it. But this is called a system because it has more than one equation. A system of equations in certain number of variables. And it's a linear system. Why? Because every one of those variables and every one of those equations is raised to the first power. Always to the first power. Okay. Now, they give us a fairly simple example of this. 3x1 plus 2x2 is equal to 3. And minus x1 plus x2 is equal to 4. Okay, that's called two equations, two unknowns.
Right.
3 x1 plus 2x2 is equal to 3, and x minus x1 plus x2 is equal to 4. Okay. Now, I don't know if you remember how to solve that. Back when we only had two equations, two unknowns, each of those equations represented a straight line in the coordinate system. You could graph the two straight lines, and the point where they cross, if they cross, is going to be your solution. Okay? Now that to me is tedious. I really am not that good of a grafter, and I'm not that neat. And sometimes the point of intersection may fall between the grid lines, and I can't tell exactly what the value is. So that's not a great way to do it for me. Now, there was a second method that we used to use, and this second equation just sets up perfectly for that. You could have just said that let x2 equal 4 plus x1, right? And then in the first equation, instead of x2, you put in 4 plus x1, and now you have a linear equation in one variable. You can solve that for x1, and then plug that back into the second equation, and you have your x2. That's called solution by substitution. That works okay for some equations with two variables and two equations with two unknowns. There are other systems like that it doesn't work so well in, especially if you have very complicated coefficients. The reason that works so well here is that second equation has both of the variables with 1 as a coefficient. One's a plus 1 and one's a minus 1. So that works really easily. But what works every time was the old method we used to call elimination by addition. Okay? And just as a quick reminder of how that goes, there are two different ways you could have done this one. Either multiply the second equation by 3, everything in the second equation by 3, that gives you a minus 3x1 plus 3x2 is equal to 12. And when you add the two equations together, you eliminate the x1 because 3x1 minus 3x1 is 0. You add those two together, you get 2x2 plus 3x2 would be 5. x2 is equal to 3 plus 12 would be 15. So x2 must be 3. And then go back and plug in, say, the second equation, and you got your answer just like that. Okay? That's called elimination by elimination by addition. Okay? Now, they didn't tell you how they solved it, but they did say x equal 3 is a solution, which we just got in our head. And when you put x of 2 equal 3 into that second equation, you get minus x plus 3 is equal to 4. Subtract 3 from both sides, and you get minus x is equal to 1, so x is equal to minus 1. Sure enough, that's your x of 1 is minus 1. So sure enough, you get your solutions that way. They just picked one out of the air. Well, they didn't. They knew the solution and said that's the solution because they both work. However, you can't just pick anything out of the air. If you say, well, let's let x1 equal 1 and x2 equal 0. No, that doesn't fit either one of those equations. So, no, you can't do that. Well, it would fit the first one, but not the second one. Because x1 of 1, that would be a minus 1 on the left-hand side, plus 0, can't equal to 4. Okay? So, you can come up with a solution, and that's a unique one and only solution. Because you have two equations, two unknowns, you're either going to have a unique solution or infinite number of solutions or no solutions. Well, we eliminated no solutions, and basically that's the only solution you can get. Now, on page 4, they have in the middle of the page sort of a discovery. They say graph the two lines. And I don't like graphing, but you certainly can if you want to. See where they intersect. How many solutions does it have? It has one and only one. So how many solutions does that system of linear equations have? Excuse me, one and only one. Now it gives you a couple more. and it wants you to graph those. That second one, you'll find out there's no solutions to the first system and an infinite number to the second system. And without actually doing those, and we haven't gotten to it in the text yet, I'd say let's just leave that alone for a moment. But once you get, well, okay, let me say this. Did you notice who the author of the book was? Ron Larson, does that name ring a bell?
Same book as every other book.
Yes. And it's not completely an accident. Larson does some things that I don't find any other author doing. Now, there may be others doing them, I just haven't run across them. He has, I don't know if you notice this in your other courses, but in Pre-Calculus Algebra, same book you use for Pre-Calculus Trig, that was by Ron Larson. Your Calculus 1, your Calculus 2, and Calculus 3 were both by Larson and Edwards, right?
All right.
Okay? Same Ron Larson. And in every one of those books, they had usually a couple of different websites that went along with the book. Okay? And this book has 2 websites. Okay? The others, I think, sometimes had more than 2. This one has 2. I'm going to hold it up for you. One of these is called LarsonLinearAlgebra.com. Now, I don't know if the capitalization matters. I know they're written all as one word. LarsonLinearAlgebra.com. Okay? And the other one's the same name he uses for all of his texts, and that's a calcchat.com. That's calcchat.com.
Yes, sir.
Okay. Now, those 2 websites give you, and they're absolutely free. You don't need a code, you don't need a key, you don't need anything else. Your grandmother could go out to those websites and read them without ever purchasing a Larson text. I mean, they're out there free for everybody. Of course, they don't make a lot of sense unless you got a text, but they're out there free for everybody, anyone who wants to look at it. And this discovery we were just talking about, you can go to LarsonLinearAlgebra.com for an interactive version of that type of exercise. And he'll actually do the graphing for you, which I find very nice to have, okay?
Yes, sir.
So even before you get your code, before you get your ebook, before you get any of that stuff, if you want to go to LarsonLinearAlgebra.com, you can see their version, an interactive version of that type of exercise. Okay. Now, this I don't think was always in the other books, but in this linear algebra, he does a lot of this. Here's a linear algebra applied. Remember your paper topic? You could do an application. He mentions in a chemical reactions, atoms are recognized in one or more substances, reorganized in one or more substances. And for instance, when you burn methane gas, that's CH4 methane, combined with oxygen and burns, carbon dioxide and water are produced, and you can write out the equation for it. And you can solve those equations using linear algebra. So what he's getting at here, chemistry uses linear algebra a lot, okay? They may not mention it that way, but you wind up using it a lot in chemistry. So if you happen to be a chemical engineer and wanted to use that fact and do a research paper looking into that, that certainly would be, or if you're just interested in chemistry, you might look at that as well. Okay. Now, they're stating again something I said to you earlier. I said I jumped the gun on it. But it is possible for a system of linear equations, any system of linear equations, It can be a huge system, a small system, any size system. System of linear equations to have either exactly one solution, infinitely many solutions, or no solutions at all. Those are always the three options you're going to have. Now, here's a couple of terminologies for you. I think I'll hold this up so you can see it out of the book rather than me write it down, because you can read it probably better from the book. Okay, if a system of equations has a solution, it's called a consistent system. If anything that will work is called a consistent system. That's if it's a one and only one or an infinite number of ones. Okay, that's called a consistent system. Okay. Of course, if it has no solutions, that's called an inconsistent system. So I'll write out, actually what I'll do is I'll type out those, okay? Okay, so consistent system has a solution or infinite many solutions, but it does have at least one solution, okay? An inconsistent system has no solutions. You can write down as many equations as you want to. You're never going to find a solution. That would be an inconsistent system of equations. Okay? So those are those two terms. Now, with that consistent system, that has either one solution or an infinite number of solutions. If it has just one solution, we call those two equations independent of each other. They just happen to cross at one point and one point only. If, however, you get an infinite number of solutions, then we say that system of equations is a dependent system, meaning one or more of those equations can be written in terms of the others. In other words, one equation depends on the other. Okay, so we haven't gotten into that part yet, but for this part, we're only dealing with consistent and inconsistent. If it has a solution, even if it's an infinite number of solutions, it's called a consistent system. If it doesn't have a solution, it's called an inconsistent system. Okay. So, they again want us to graph. And my word, I don't have any. I was hoping something here was going to have graph paper on it, and it doesn't. If you remember back, I don't know if you saw it or not, but when I had the writable screen, I had one that was a blank screen like this, and I had another screen that was a grid. And the grid is what I could draw graphs on. I don't have a grid here. I wish I did, but I don't. Okay? And it says solve and graph each system of linear equations. So let's do the best we can with this. I think I'll do it on paper. And in fact, I do have some graph paper here. And I know we have some more downstairs. So I think I will spring for using some graph paper. Really get carried away. I'm stingy, so I'm reusing somebody else's page from a test or something, or a homework exercise or something. So here's the first system of equations. First equation, x plus y is equal to 3. Second equation, x minus y is equal to negative 1. Now I want to thank them from the bottom of my heart for making it such an easy system. Okay? Do you see it?
Yes, sir.
Okay. And just looking at that, I say I can solve that system without drawing a single graph at all.
All right.
All you have to do is add the two equations together. And that gives you 2x, and the y's add to 0, right?
Right.
is equal to 2. So x must be equal to 1. Do you see that? Okay.
Yes, sir.
All right. So we got x equal 1. Okay. So there's the first part of the ordered pair. Let's go back to that first equation again and put in a 1 instead of the x. 1 plus y is equal to 3. What's y equal to? 2. Okay. So y is equal to 2. There's your solution. One and only solution. That's a consistent system, and those two equations are independent of each other because there's only one solution. Okay? Now, if we were to graph that, okay? Okay? The x plus y is equal to 3. When x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to 3. I think I can draw that line that connects those 2 points together. Okay? Would you agree that worked?
Yes, sir.
Okay? So there's the graph of the first equation. Now the second equation is a little messier. And I'm going to suggest that we write that in slope-intercept form, because that's really easy to do. You could do it the same way we just did, but it's really easier to do that. So let's add y to both sides. That'll be a y on one side is equal to, that leaves the x on the other side, and we're going to move the minus 1 over to be with the x, so that's going to be a plus 1. Okay? So do you agree that would be the second equation, written in slope-intercept form?
Yes, sir.
Okay. What you do is solve for y. Okay, now I know looking at that, the y-intercept for this equation is 1, because it's mx plus b. So 0, 1 is going to be my y-intercept, and it has a slope of plus 1. Okay, I just filled in the blank there. I wish I had pens of different color. That would have worked. And look at where our solution is. X equal 1, y is equal to 2. What was our solution here? X equal 1, y is equal to 2. One and only one solution. Right there. The ordered pair, 1, 2. And that's exactly what we got by elimination by addition. I found elimination by addition much easier than graphing. This was an easy problem to graph, but still took time to write it out, do that kind of stuff. Okay, I almost promise you the next one will not be quite as easy, but let's see what we get. X plus y is equal to 3, and 2x plus 2y is equal to 6. Okay, here's our second system of equations. Can you see it?
Yes, sir.
Okay. Now, if you're not used to looking at these, you may not recognize it. But if you, by the end of this term, you'll recognize it. Notice that second equation is just the multiple of the first equation. Right?
Right.
Just 2 times the first equation gives you the second equation. Guess what?
Right.
Same set of points that will give you solutions for the first one, going to give you the solution for the second one. Okay? In fact, I'll give you 2 points right easy. 3, 0. And if you put a 0 in the y, you get 2x equals 6. X equals 3. 3, 0 works again. 0, 3 works in the first equation really easily. Put a 0 in for your x, you get 2y is equal to 6, y is equal to 3. Sure enough, every solution for the first one is going to be a solution for the second. So guess what? That's a consistent system too, but it has an infinite number of solutions. Okay? And if you were to graph those two, I'm going to do a new graph here. What were the points I used? Again, 3, 0 and 0, 3. And you plot those. Then you do the next one, and it plots right on top of it. It's the same line, so no wonder it has an infinite number of solutions. Every point that's on one is on the other. It's also a consistent system because it has solutions. In fact, it has an infinite number of them. But this equation depends on that one, because you just multiply this one by 2 and you get that one. So that's a dependent system. They haven't hit that yet, but we will in the later. All right, now let's do one more set. X plus y is equal to 3, and x plus y is equal to 1. Okay? Now, since the first equation is the same as that one, and that just graphs like that, I'm going to leave it alone. That's going to be my graph of the first one. The second one, points on it will be 1, 0, and 0, 1, and everything that connects those. So that would be here, and every point that connects those two. Okay? Here is x plus y is equal to 3. There's x plus y is equal to 1. What do you notice about those two lines? Now, mine don't look like it, but what do you notice about them?
Parallel.
They're parallel. Are they ever going to intersect?
No, sir.
No. So that's going to be an inconsistent system. Two perfectly good lines, but there's no points in common. So that's an inconsistent system. Okay? Now, I guess I should have, if I had looked far enough ahead.
I think we ran out of time.
You are right, we did it. Now let me just show you this. This is their picture of it, isn't it?
Yes,
There's
sir.
that first one crosses at 1 point only, 2, 1. The second one lines up on top of itself, and the last one, they are parallel to each other.
Right.
All right, we will pick up next time with, we've basically already done what's at the bottom of the page, so I'm not going to repeat that. We'll pick up at the top of page 6. Okay?
Yes, sir.
And we will go from there. So if you happen to get your book or ebook or whatever, we'll pick up and go from there next time. Okay. And I'll save that in case we need it later. I'll put this in its place. All right, good deal. Hope we didn't lose Ricky, because I think she had seen the thing before, but she must, I don't know. Hopefully she'll see. I'll try to get it right next time. Okay.
Yes, sir.
Now, I don't know how I just did that. I think I laid my computer down or something on my elbow or something, and it just put a plus, a bunch of spaces, and then another plus. That's immaterial. Okay. All right. Good deal. Good to see you. And we will see you on Tuesday. Have a good weekend. Nice, safe Memorial Day weekend. Okay?
Yes, sir.
Thank you.
All right.
Bye-bye. Okay.